Hi, hello, welcome back. So what will happen if you put too much current through your resistor? I'll show you a video to demonstrate what will happen if you do that. So see, this is what will happen. Once you put too much current through your resistor, you see it starting to burn slowly. Starts to burn slowly. Now this is showing you until it becomes red hot, then until it fails totally. So that means that a resistor is not designed to work at all level. So that brings us to the place of explaining the power rating of a resistor. Now you have to take this carefully, understand this carefully. The power rating of a resistor. In our previous classes, I showed you different sizes of resistors, and I told you some are 0.25 watts. I told you some are 1 watt, some are 2 watts, 3 watts, 5 watts, and 10 watts resistor. What is the significance of this wattage or power rating? I will demonstrate it for you using a calculation. But before I do, I had to repair a fan some times ago. So I want to use this example to explain to you in areas where you may need to really look into how much power your resistor will demand. So it was a rechargeable fan, and there was a resistor that was connected in series with a battery to charge the battery. Howbeit, I discovered that when the battery is totally dead and you want to revive it, it pulls so much current from the resistor and it gets really hot. Why it is not going to fail, just like the video we just watched now, but two things are possible. It's going to shorten the lifespan of that resistor. That means that resistor would fail eventually, maybe in the next 1 year, in the next 6 months. Or as it was doing already, it was gently melting the plastic cover that was used for the fan. You see that? And as a designer, a designer that you would become, these are the things you want to avoid in your designs. So in what areas when you are designing, what circuit should you be designing, and you have to consider the rating of the resistor you are using? Number one, if you have to use a low resistance value, and for me, I will take low resistance value from 100 ohms downward. 100 ohms downward. If you have to use a low resistance value, 100 ohms downward, you may have to look into how much current is going to flow through that resistor. Number two is that what are you connecting that resistor to? Are you using it to charge a battery like what I described earlier? If you are going to be using it for power circuit, things that requires power, charging a battery, making your own custom power supply, or something that's going to be drawing, you know that what you are connecting this resistor to is going to demand a lot of current. You may have to watch out for how much power. But if it is a light emitting diode, the common ones, the ones you see in your stabilizers and all those small ones, the power may not be that significant. But if it's a special light emitting diode, maybe the ones in huge torchlights, there are some torchlights that are 100 watts. Maybe it's so very bright torchlights, we have to consider also all of that. Now, let me teach you how do you uh, know the power that is going to that your resistor is going to consume. How do you know the power? We're going to have to do calculations, right? It's not going to be boring, I promise you. So let's go back to our calculation board. Let's go back to our calculation board. Now, remember the voltage divider that we worked on in previous videos. But let's not do voltage divider this time. Let's just do the normal resistor and the voltage source circuit. So I have this. Let's say I have this battery. Let's say the battery is 9 volts. 9 volts, 9-volt battery. And I have this resistor connected, and I have my load. Let's say the load is a lamp. Or okay, let's just use our voltage divider so I can explain something. So the voltage divider circuit looks like this. Now I told you earlier that we should watch out for if the values of the resistance are low. Most likely you have to look into how much current it will eventually consume. You see that. So this is the output. This is the output. Your output and your input is 9 volts. In the last voltage divider, I remember was 1 kilo ohms and 4.7 kilo ohms. But let's say we now use 10 ohms and 47 ohms as the value of our resistor. The value of current drawn from this 9-volt battery will now be I equals to V over R. V stands for voltage, R stands for total resistance. And don't forget our voltage is 9 volts. So I'm going to put letter 9 there, figure 9. And our resistors are 10 and 47 ohms. So I'll put 10 plus 47. Since they are in series, do you remember series parallel connection? So their total resistance will be 10 plus 47. This will give me 9 over 57, right? 9 over 57. So that will give me 9 over 57. And that will result to how much? Let's punch a calculator. 9 divided by 57 will give us 0.158. Let's just keep it at 0.158 ampere. Yes, you may think that this is not a lot of current since it's still 0 points, but wait till we do the calculation, finish the calculation. So, if you want to know the power that will be flowing through each of these resistors or the power that will be demanded by each of these resistors, the formula is simple. Power P is equal to I square R. I square R. Please don't mind this formula. Now, if you do a little bit of mathematics by putting, replacing I here, substituting and all of that, you're going to get different formulas for power. You can also have power is equal to V square over R. Right? Or power is equal to IV. I current multiplied by voltage. This is not a mathematics or a physics class anyway, but when we need these formulas, we will bring it back. I suggest you have a book where you write these things so that when you need them, you can always refer to it. You can come back to watch this video. All right, let's continue. So the formula of influence is I square R. Since we know the I, so that will leave us with 0.158 square multiplied by R. Now we could calculate the total power flowing through the resistor, but that will not help us know what should be the power rating of each resistor. So I advise you do individual resistors. So the first one is a 10 ohm resistor. So by the time we press our calculator, 0.158 square, that's 0.158 in two places. 0.158 divided by 0.158 multiplied by 10. That will give me 0.25 watts. Sorry for using O. 0.25 watts. Unit of power is watts. Now 0.25 watts. Remember, in a previous video, there is a resistor that is exactly 0.25 watts. Now it will be a terrible mistake to go ahead and use exactly 0.25 watts in this scenario because it's going to fail. resistor will burn out because you are using exactly the same power as it will draw. So you must give headroom at least times two. So if I were to be using this circuit, building this, I will go for 0.5 watt resistor, or more importantly, I'll go for 1 watt. So like that, it has enough headroom to accommodate the power stress, and hence your component will last longer. Do you get it? I hope you really do get it. If you don't get it, you can drop a comment for me and we'll follow it up. Alright, now let's calculate for the second resistor. Let's calculate for the second resistor. Now you see what I'm talking about. For the second resistor, the same I square half, power is equal to I square half. If the same current flowing through them, since it's a series circuit, that will also give us 0.158. 0.158 square. Now multiply by 47. Let's see what that will be. 0.158 multiplied by 0.158 multiplied by 47. 1.17 watts. 1.17 watts. You see now, 1.17 watts. That's the total current that was going to be total power that's going to be demanded by the 47 ohm resistor. You see how different it can be. So that means that it would be a mistake to think that because this one is, I use 1 watt here, I will also use 1 watt in the second case, the second resistor. So when you are building a power sensitive circuit, when you want to drive an electric motor, you want to drive a drilling machine, or something that is, you know that this thing is likely going to require heavy current, do well to calculate how much power it is going to draw, and then choose the power rating of your resistor accordingly. So for example, if I were to choose the power rating for this 1.17 watts, I'll go for 2 watts. So 2 watts is not bad, or better still, I'll go for 3 watts, which makes it more better. It's going to be bigger, but your circuit is going to be safer and it's going to last longer. These are what developers and people who build these circuits know, and that's why I'm teaching you this thing. Do you understand? So let me tell you a little story before we close this video. I once did a project for a client, solar optimizer, and in there it requires that we step down 48 volts DC battery voltage to 12 volts, and I built a circuit to do that. And I discovered it was working fine when it was me, but I gave it to them, and after 2 weeks they called me back and to tell me that the project is no longer working. So I was a little bit worried and like, what happened? So I had them send it back to me. When I opened it, it was just a resistor that I did not properly factor in how much power would be flowing through that resistor. A single resistor can mess up your work. That's what I'm trying to say. So you have to pay attention. As a beginner, if it's possible, calculate everything. Calculate it so that you will be in a safe place. Thank you very much. You can drop your comments, you can ask questions, and I'll be there to attend to it. Bye.